All right, so we want to estimate the area of the surface generated by revolving the curve y equals cosine of 2x from 0 to pi fourths about the x-axis. And then they want us to do this using trapezoidal rule with 5 subdivisions. All right, so there's kind of a lot to unpack here. This is a really dense statement. So I think it's good to write out the things that we know right from the beginning. The first thing that we know is that f of x equals the cosine of 2x. And the next thing we want to know, or the next thing that we do know, is that the area that we're trying to figure out for this function is between 0 and pi fourths. So this is going to be an integration problem from 0 to pi fourths for cosine of 2x. All right. So not only is it just an integration problem for this curve on the Cartesian plane, we want a surface area of the curve rotated or revolved around the x-axis. So the way that we're going to do this is by using this equation right here. This equation is the equation that describes the surface of revolved solids, and it reads as follows. The integral from a to b for the surface of a revolved solid is 2 pi times the function times the square root of 1 times the function's derivative squared. And we're going to do this, but before we do this, we're going to apply the concepts of the trapezoidal rule. And that's the function here as followed. And this bit right here is really just a clever way of saying all of the terms for each subdivision have a 2 in front of them instead of the first and last one. So why don't we get started here? So I'm going to start plugging in some values into this function right here. So we have the integral from 0 to pi over 4 equals 2 pi cosine 2x square root of 1 plus the derivative of cosine squared. So I'm just going to leave that like this for now. So let's go find that derivative. So the derivative of cosine of 2x is negative 2 sine x. And I got that using the chain rule. So this is a negative 2 sine x. So our final expression is going to be the integral from 0 to pi fourths. I'm going to take this 2 pi out since it's a constant multiplier, or a constant coefficient, of cosine 2x times the square root of 1 plus 4 sine squared x. All right, so now we have a real integrand. That's great. And since we're going to be using this quite a bit with the trapezoidal rule, I'm going to, for the rest of this video, call this function right here, this integrand, p of x. The p is for no discernible reason. I just think it's going to shorten things quite a bit, and it's going to make the process a lot more efficient. So real quick, let's copy this for the next slide, and let's start applying the trapezoidal rule. So we earlier said that we have 5 subdivisions, right? So we know that n equals 5. And our a is going to be 0, and our b is going to be pi over 4. So with this information, we can calculate the change in x, which is b minus a over n. And we can say that the change in x is going to be pi fourths over 5, which is the same thing as pi over 20. Now, we also know that this value right here is going to be placed in the numerator divided by 2. So we know that that coefficient in front of our whole expression is going to be pi over 40. So I'm just going to use this now, and I'm going to start plugging in our expression into the original trapezoidal rule. So I'm going to move things up a little bit here. Okay, so we have that the integral from 0 to pi fourths for cosine 2x square root of 1 plus 4 sine squared x dx equals pi 40ths times f of 0. So I'm not going to use f here. I'm going to use p, like we talked about. P of 0 plus 2. And then remember, our change of x is what we're going to be using here, and it's pi over 20. It's kind of a gross number, but let's kind of just go with it. Over pi over 20 plus 2 times p of 2 pi over 20, which is just pi over 10, plus 2 of p of 3 pi over 20, plus 2p 4 pi over 20, which is just pi over 5. And then we did it. We're all the way back to p of pi over 4. Okay, so this is going to be what our expression looks like. I highly recommend putting this into your calculator, defining the function p of x as cosine 2x square root 1 plus sine squared x. And that way you can kind of save yourself a lot of time, a lot of computations, and you can find this value. So at this point, it's also important to remember that because this is a surface of revolution problem, we are approximating the area, but we still need to multiply this by 2 pi. That's really important. Otherwise, your value would not be correct. So keeping that in mind, why don't we reduce this a little bit? Because this is getting a bit messy. So we have 2 pi times pi over 40. And then this whole expression is going to become some number, right? We know that these are actual numerical values when we plug them into the function. And I'm just going to call this whole thing alpha. So it's pi over 40 times alpha. And this value, when you plug it in, is going to be around 4.8812. And that is how you would solve a problem like this. Now, I recognize that I didn't do these computations by hand, and that might be confusing for some, but what this consists of is taking the value listed within each one of these parentheses, whether it's 0 or pi over 20, and plugging it back into this solution, making sure you respect this 2 coefficient whenever it's present, and then adding up all those numbers. So this is a problem dealing with sums, and I'm not going to compute all of them, but I hope that this video gave you some guidance on how to apply the trapezoidal rule to this problem without having to get too caught up worrying about the surface of revolution.